Hi, welcome to this lecture. So in this lecture, we'll talk about what Google Colab is. So to get started, let's type in Colab on Google. Colab. So enter, and you can see here encyclopedia and also the main Google Colab site. So colab.researchgoogle.com. So Colab is one of the Google research product. So it's more like, if you know a Jupyter notebook, it's more like a cloud-based Jupyter notebook dashboard. So you don't have to manually install some libraries on your Conda environment or on a local machine. It's just taken care of for you at the Colab in the cloud. So it's a cloud-based Jupyter notebook, so to speak. So and it's free. And then one of the things that you need to access Colab is you need a Gmail account, and if you have a Gmail account, you need to have your Google Drive, and then you can create a Colab notebook, something like you create a Jupyter notebook. Okay, so what's Colaboratory? So a Colaboratory, or Colab in a short form, allows you to write and execute Python in your browser, and it has a zero configuration required. So if you were to do a Jupyter notebook, you need to configure some and install some package, but here you just need to import some package. You don't have to configure. And then you also have access to GPU and easy sharing of your codes. Technically, you just share your Colab code with other collaborators, and it's fairly straightforward. So how do you create a Colab notebook? So you need to go to your drive, your Google Drive, and then create a new Colab. You see Google Colaboratory, you just create a new, and then it will give you an option to create a new notebook. It's just like a Jupyter notebook. So you can rename your Colab notebook, for example, test1, and dot, that's a notebook suffix, and then you have runtime and edit and file. So you can save your file as a copy in your drive or in a GitHub and things like that. But basically now we don't do fancy things here. And also you have different cells. So this is, when you click this, you add a cell that's executable. So you write a code, for example, import numpy, then you can execute this code. It will import this package. And also you have a text cell where you can, for example, let me just move this app, and then you can, for example, write import, I don't have to just comment it, package. So you can execute this, then it will just consider it as a text. It will not, because it's import, it's considering it as let me just make it a human readable, a sentence, so that it will consider it. Let me just add a cell, which is all right. So I can change the font type to bold and what have you. Let me just tell it, actually, import package, and then this is a text. So because this cell was added as a a code cell so that it's assuming it as a, you can also delete a cell, so let's delete that. So this is a text. You can write anything, any text about this code, and you can also add a code cell. So technically it's more like a Jupyter Notebook, but a cloud hosted environment. And the advantage is, you know, you don't have to you don't have to, you know, configure some package, and then unlike a Jupyter Notebook. We have discussed Google Colab in the previous lecture, so let's discuss about what Google Earth Engine is. So first thing first, let's type in Earth Engine. So Google Earth Engine. So Google Earth Engine is a cloud platform by Google, which is used to analyze and store a large volume of Earth observation data or geospatial data. And so this is the website of the Earth Engine, or the Google Earth Engine site, and you need to have access to this account. You need to sign up to create an Earth Engine account, mostly free for research and educational and nonprofit purpose. So you can request access for a Google Earth Engine account. Once you have access, you can access a large volume of Earth observation data in the platform. You have, you know, climate and weather data, you know, temperature, and satellite image, including Landsat, Sentinel, you know, MODIS, and other geospatial, you know, data, including crop type, land cover, and nighttime light. And there's more than that. There's a large volume of data. These are just only a sample subset of what you have on the Google Earth Engine data library. And the other thing in the Earth Engine library is the platform. So there's mainly a code editor for the JavaScript API. So if you click the code editor, that's what you find here. So this is a playground. You can write your code here, mainly a JavaScript. You can write your JavaScript here, and you can execute and run, and you can see some of the output map result here in the map canvas. The other, so Earth Engine has two APIs. The first one is the JavaScript API, which is the main platform, and the other one is the Python API. So the Python API is run using a Jupyter Notebook, and also a Colab, a Google Colab, which we have discussed in the previous lecture. So by running a Google Colab, you can access the Earth Engine platform. Hi, welcome to this lecture, and in this lecture we'll talk about getting started with a Colab notebook. And so as you can see here, I need to initialize, first import Earth Engine, import EE, will import Earth Engine. Mind you that unlike a Jupyter Notebook, Earth Engine is already integrated in Google Colab, so we don't need to install Earth Engine, a standalone Earth Engine package. And then this will authenticate the Earth Engine library, and ee.initialize will initialize it so that we can access it in a later part of this script. So let's so the first thing first is this chunk of the script. Let's run the cell and see what's going on. So it will ask me authentication. So I'll click this link and go to my my email and allow for the Earth Engine app, and then click this, or just copy that and then click and then Control V or paste and then enter. That will successfully, so I have this message, just successfully saved an authorization token. So that means I'll have access to the Earth Engine Python API in a Colab environment. Then, so the main part of our script here is I'll import countries database here and filter a country. In this case, I'll use Ethiopia as an example. And I'll also load the USGS SRTM data. Here, dm is equal to ee.image. And then I'll run this script. This will import my SRTM data and country's boundary. And the last thing is just to display a map canvas. So, we'll be using a Folium library. So import a Folium library and then define a function for our map canvas, and also define some visualization parameter here, some color palettes and minimum and maximum, and our zoom level, and a lot long information for our zooming location, and mainly import that DM data here. So I'll just run this entire script and we'll be able to look at my DM result here. Excellent. So as you can see here, using a Folium package, we can in a Python API environment, we are still able to visualize our data in a map canvas using the Folium package. So this is a DM digital elevation model. There's layer here. You can check it and uncheck it to remove and add that layer in this map canvas. Hello, welcome to this lecture. In this lecture, we'll use the Landsat image loading using a Colab environment. So we don't need to install the Earth Engine package as it is integrated as part of Google Colab. And what we need is to import. So here I'll write import EE, that will import the Earth Engine package, and authenticate and initialize will authenticate and initialize the Earth Engine package. I've already done that. If you haven't done or authenticated, so please go ahead and run this part of the cell. I've successfully authorized it, so I don't need to do that again. So the main part of our script to load a Landsat imagery is this chunk, and the first thing before we do that is to import countries database. Since Landsat is a global data, we just want to focus on some study site, and in this case I'll import the global countries boundary database for 2017, and using that I'll filter a country. In this case I'll use Ethiopia, and this is my image collection here. So ee.image collection, and then I'll provide the image collection ID, which I'll get from the Earth Engine data library. And I'll do a couple of filters. The first one is temporal filter. So filter date will filter the date here, in this case January 1st 2017 to December 31st 2017. So it spans for about a year, and also I can filter by space. In this case, filter bounds will filter it by that specific location that I've already provided earlier. And you will also need to do some, because we're we're doing some visualization. We need to select, the different band combination. In this case, band 4, 3, and 2 for the Landsat 8. And also because this is an image collection every 16 days for the entire year 2017, that's a lot of data, so we need to do some sort of aggregation. So I'll do a median stat, which will calculate the median for each pixel. It will calculate the median value for the entire year for the selected bands, band 4, band 3, and band 2. And finally, using the Folium package, I'll import Folium and then write a function that can create a map canvas using the Folium package. And before I do that, I just need to create some sort of visualization parameter, define minimum and maximum value of my Landsat data. And finally, I'll just provide my input image to the map function. My map function is already defined here, like the add layer function is already defined here, and then it will map it to this location, my map here, my map.add layer. So I'll just give it a name, Landsat Media, and it will show up on the right side of the image, and that's it. I'll just click that and should be able to visualize the Landsat image for 2017 over Ethiopia. I'll just uncheck this. You can see that here. So this is a median Landsat aggregate data for 2017. As you can see here, it's more like a true color composite. You can see some cloud. We haven't done a lot of cloud masking. That's why we're just seeing some cloud data. So yeah, this is just a very simplistic approach to load Landsat data using the Python API and a Google Colab. Welcome to this lecture. So in this lecture, I'll teach you how you can do some band maths or band combination of an image, in this case a Landsat image, and using the Earth Engine Python API and Google Colab environment. So if you have not authenticated and initialized Earth Engine, use this part of the script to do that. Since I already have done that, I'll just go ahead and start to the main part of the script. So I'll load a Landsat image. In this case, I'll have to write what I'm doing. So this is not part of the code, it's just commented, so it's Python is not reading that. So that I remember, I'll write the title of my script, load 2.5 Landsat 7 composite. So I'll name a variable called Landsat, and the first year is 99. So I'll use 1999. So this is a variable name. You can change it if you want to. And then I'll cast EE image, since I'm importing an image from the Earth Engine library. So I'll write the image ID that I'll be using. I'm using Landsat 7, so I'll write Landsat E7. And it's a TOA, that means top of atmospheric reflectance. It's a 5-year composite. And the year is 1999 to 2003. So that's my first data. And the other one is, I'll actually copy this since I'm slightly changing the year to save time. So my second variable is Landsat 2008, and the only thing I change here is the year range. Okay, 2008 to 2012. So I'm importing two images from Earth Engine. The first one is a 5-year composite, which I'll name 1999, and the other image is a Landsat 7 5-year composite, which I'll be naming as Landsat 2008. Okay, and the next thing is I'll actually need to add more cells so that I run my script. Okay, so the next part of the script is I'll write a function that calculates NDVI. Okay, so, and I'll just use, there are two ways you can calculate NDVI. The Earth Engine built-in normalized difference function, and also I can use some band math. Okay, so let me use the first approach here. Compute NDVI the hard way. So this is the difficult way, all right? So the first thing is to start my function. I'll name it. For example, I'll use the Landsat 99 image using this approach. Okay, so I'll import that Landsat 1999 here, and I'll use that, and then select the different bands. Okay, for my calculation, I'm calculating here NDVI, normalized difference vegetation index, and I'll select the bands, band 4 in this case, and then I'll subtract again Landsat 1999, and then I'll select a band, in this case band 3, and divide, that's a denominator, and then Landsat 99 again, and then select a band, again band 4, and I'll, instead of subtracting, I'll add, and then open a bracket, and now Landsat again, I'll select a specific band here, in this case band 3, Landsat 1999, and select a band, in this case band 3. Now this is my function that calculates NDVI for the 99 data. So the second approach is using the Earth Engine built-in NDVI function. Okay, so I'll compute, I'll write the title of my function, compute NDVI. It's an easy way, so we're gonna do the easy way of calculating NDVI. Okay, now instead of the 99, I'll use the 2008 Landsat data for this calculation. Okay, so I'll name it NDVI 2008. That's my variable, and I'll import this image, the 2008 image here, and I'll paste it here. And then instead of selecting the different bands, in this case I'll import the normalized difference Earth Engine built-in function. Okay, normalize difference. So this will this will just simply you input the two bands that you're using for this calculation, and then it will automatically calculate NDVI. So it's a built-in Earth Engine function. And the second band is band 3. That's it. That's simply it. You need to, since it's a list, you need to have a bracket here. So you can see that the first way we did, we just simply used, so in the first example, we used math band by subtracting and adding the different bands, which is the easiest way, the difficult way. The long way of doing that, the other way, is using simply the Erzingen built-in function, which can calculate NDVI if you provided the two bands that you're interested in this case, band 4 and band 3 of Landsat 7 image. Okay, so now next, let's create our visualization parameter here. So this is the visualization parameter here, and I'll name it NDVI parameters. Okay, so I remember what it is, and then as always I'll open a curly bracket and then name palette this way, and then just list the different colors that I want to be used in this mapping. You know, don't worry about, you know, the color codes that I'm writing, and if you want, you can go to Color Brewer as always and just check the different color codes. You know, if you want green, for example, here you can, you know, change it to 7 or 8, and you can simply pick, you know, copy the color code here and then paste it on your Erzingen color palette. So you don't have to worry about, you know, the color codes, and you don't have to memorize them. You can always grab them from the Color Brewer. Okay, so don't worry about them if I input them. So I already created them beforehand. So my first color code is D73027, and then I'll add a second one. And the second color code is ampersand or hashtag FDAE. Sorry, this is not the right one. So F4 6D 43. And let me create the next one. The next color code is FD AE 61. The next color code is FEE 08B. Let me do the next one again. T9 EF 8B. Next one is A6 D9 6A. I forgot to include the quotation. You can use a single quotation or you can use double quotation. It really doesn't matter. And the next one is 66 B D6 3. The last color code that I'll be using is 1A 985 and 0. I need a quotation. This case I'll be using single quotation. Okay, now let me execute the first part of the code. Okay, fantastic. So now to save time, let's import the map canvas script, which I've already written to save time. So in this script, mind you, we're gonna these are the most important parts of the function. So the first one is we're gonna display the NDVI, the 99 one, and the second one is we'll display the 2008 NDVI, which we used different approaches. The first one we used, you know, the hard way of calculating NDVI, and the second one we used the Erzingen built-in NDVI calculation. We just casted normalized difference Erzingen built-in function. So let's see if there are any major differences, you know, by using the simpler way and the hard way of calculating NDVI. and then I'll name them NDVI 99 and 2008. And let's execute this part of the code. There's some error here. Landsat 2003 is not found. Some error here. Oh, it's because of the TOA. Okay, fantastic. Okay, great. So we're using the global, Landsat data for the entire planet. You see, so we have used the image, the image for the 2009 5-year Landsat 7 TOA composite for the year 1999 and 2003. The second one is a 5-year Landsat TOA, top of atmospheric reflectance composite, for the 2008 and 12 period. And then we have used two different NDVI calculation approaches. And mind you, this is a global data. It's for the entire planet. So let's just check each of them one by one. So the first one is the NDVI 1999, okay? And the other one is the 2018. So this is a 5-year composite starting from 1999 to 2003. So it's a 5-year, composite. And so it sounds like during this period, there's some sort of dry drought and mostly, lower NDVI, which indicates lower vegetation overall in that period. And then if you look at this 5-year period, relatively it's just wet. So if you want or interested to do it for specific, this is a global data, and that's the power of Google Earth Engine. If you were using your local machine or something like that to calculate this large volume of data, it might take you days or weeks. But with the power of Google Earth Engine and cloud computing, you can analyze and just run, calculating big planetary geospatial data in a fraction of a second. That's amazing. So, and if you're interested to calculate this for a single country or specific study area, you can use, the clipping function and other spatial analysis, tools to zoom into your study area. Okay.